All right, so hopefully y'all have had a chance to look at the graph or look at this equation and kind of get some information, but now as you can see, I found a bunch of information. The degree is 4 because we're getting 1 from this front, a second one here, and then 3 and 4 coming from that last parentheses. Turning points is 1 less than that, so 3. The x-intercept, set them all equal to 0, that all the different factored form, and you get x equals 0, 2, and -3. -3 is going to be known as a double root because it happened twice, but for right now, we're going to list it as once, and then our y-intercepts, when we go in there and plug in 0 for all of our x values, we'll just get a y-intercept of 0. Our sign chart, by the time we use our 3 x-intercepts at -3, 0, and 2, and pick some numbers in between to plug in, we'll find out that we're only going to be above the x-axis from 0 to 2, and we're below the x-axis from -infinity all the way up to -3, from -3 to 0, and then from 2 to positive infinity. All right, our last but not least, our end behavior, because our degree is even, that tells us that either both ends are up or both ends are down. But because my leading coefficient's negative, and how I know it's negative is go in the very front, I finally got a negative sign sitting over there, that it's actually going to be both down. So my y values are going to go down as I go left on this graph, and my y values are going to go up as I go right on this graph. So kind of putting all this information together, see if I can fit it all in here. We have an x-intercept here at -3, one at 0, and another one at 2. Our y-intercept is only here at 0, so we can call that done. And behavior says I should be eventually down on the right and down on the left as I finish out going past my x-intercepts. At -3, I'm going to be coming from below and then staying below. So up here at -3, I'm going to touch it and come right back down because I can't cross. At 0, I'm going to be below on the left and above on the right. So that tells me that at 0, I'm definitely going to be crossing through. And at x equals -2, I'm going to come from above to eventually going below. So I'm not sure how high this hump's going to go, but it's eventually going to come back down. And I love touching that button, don't I? And then coming right back through at 2. And we can call it done. So here's a good example again of what this function f of x is going to look like. So for our last and final example, why don't we do the same thing? Why don't y'all pause it, see what you can do first and foremost, and let's come back and see what we got. Let's compare some answers. All right, so let's come back and check our answers together to see what we've got. The first thing I noticed when I looked at this function was the fact that it's factored, but it's not fully factored. That really that x squared minus 4 is a difference of squares, so I could have written it as x minus 2, x plus 2. So if you picked up on that, great. If not, don't worry about it. It's, you would have picked it up eventually by the time you got your x-intercepts. So the degree is 5 because that x cubed is telling me that x equals 0 is happening 3 times. Then we've got one more x-intercept coming from here and another one from there. So we really have a total of 5 potential x-intercepts. Our leading coefficient is 4, one less than that. So right here, what I did was, just in case you didn't see it, I went and started the original function to find our x-intercepts. I set it equal to 0. And then so if you set each part of the factored form, so the -2x cubed equals 0 and x squared minus 4 equals 0, you would have seen, okay, here's x cubed equals 0, so this is basically happening, if you wrote it out, x equals 0, x equals 0, x equals 0, so there's 3. And then we have x squared equals 4. If you finish solving it, you take the square root of both sides with a plus or minus, you can't forget that, and they'll give you a plus or minus 2. So there's our 5 potential x-intercepts. Our y-intercepts are when we plug in 0 for the x's, and by putting a 0 in for that front x cubed, 0 times anything is going to wipe it all away and give us a y-intercept of 0. Okay, so I went up here, did a sign chart, put in our x-intercepts of -2, 0, and 2. I tested. At -3 came out positive, at -1 came out negative, and then at 1 came out positive, and 3 came out negative. So we're above everywhere left of -2 and everywhere between 0 and 2. And then we're below the x-axis everywhere between -2 and 0 and 2 to infinity. Okay, so again, all this above and below part, it's all in perspective to your x-intercepts. Our end behavior, because our degree is odd, it was 5, and our leading coefficient is negative because we had that -2 out front. So an odd degree tells me that my ends have to be split, and a negative leading coefficient tells me I should be up on the left and down on the right, or that my y value should be going to positive infinity as I go left on the graph, and my y value should be going to negative infinity or going down forever as I go right on that graph. Okay, so let's see if I can squeeze a graph in here before I have to erase anything. We have x-intercepts at -2 and +2 and at 0. We have a y-intercept only at 0, so we're going to leave that right there in the middle. My end behavior eventually says I need to be leaving that last intercept up on the left and my last on the right down, going down. And then in between, at -2, I'm going to cross. So I'm going to go from above to below. Okay. At 0, I'm going to go from below to above. So we can kind of do this if we wanted to. And then at 2, I'm going to go from above to below. So I'm going to come back through. And all I've got to do is decide, how far do I want those dips to be? And then, again, to finish this up, there's a good estimate of what our graph for f of x is going to look like.